If you're listening to this on or around August 14th, 2020, Perseverance is about 2 weeks into its 7-month journey to Mars. It's traveling more than 300 million miles to touch down in February 2021. So far in this podcast, we've talked about what we know about Mars and what we're hoping to find out. And we've taken a guided tour of SuperCam, an instrument on Perseverance that's going to help search for signs of ancient life on the Martian surface. But in order to do any of that, the rover needs power. It requires a dependable flow of electricity to help it navigate the sub-zero temperatures of Mars. With no charging station for millions of miles around, Perseverance will instead rely on a kind of battery like no other. I'm Lexi Petronas from the Los Alamos National Laboratory of Public Affairs Office. Over the next few weeks, we'll be talking to some of the people on the elite teams behind specialized instruments on the Perseverance rover that will capture images, sound, and brand new data from the Red Planet. In this episode, Laura Mullane from the Public Affairs Office speaks to several experts who have unique perspectives on Perseverance's unique battery. They'll help explain all about radioisotope thermoelectric generators, also known as RTGs, which are what it takes to power a rover on another planet. Welcome to Mars Technica.
Jackie Lopez-Barlow is the Radioisotope's Power System Program Manager at Los Alamos National Laboratory. That means that one of her responsibilities is overseeing the development of nuclear power sources for spacecraft. That's a lot of science, but her path began with art. In fact, her mother worked for Georgia O'Keeffe. Jackie grew up in Abiquiu, which is about an hour north of Los Alamos, and it has a population of fewer than 300 people. It's a very small little village, and it was made famous by Georgia O'Keeffe. So that's a big leap from the small village in northern New Mexico to a premier scientific institution. So can you tell us about that, how you got interested in your work?
Well, my family had always worked at the lab in one fashion or another. I had an uncle who worked there, an aunt, but I had never really been exposed to exactly what they did at the lab other than what stories I would hear. My mom dealt a lot with museums, and so we would travel a lot with her, and I actually started spending a lot of time at the National Gallery of Art because she would have meetings there to meet with the directors on stuff that had to do with Miss O'Keeffe's artwork. And so I started getting to go other places within the galleries. So I actually spent time in the conservation lab. And so that got me really interested in what I could do from the sciences. So I was like, oh, wow, all the different instrumentation that we were doing and how they were able to look at artwork that was hundreds of years old and clean it, and just how they did it, their whole process. So that's what really got me interested in looking at science when I was in middle school, then in high school, and when I finally had to decide what I was going to do for my degree at UNM, I decided to go into chemical engineering, which I really liked engineering, and I had always been really good at math. So I just put both together and got my chemical engineering degree.
You have a good story about wasn't it the art conservators who helped you after you spilled Coke on your dress before going to the White House? Can you tell us that story?
It was actually ice cream. At the White House, they were going to hang one of Miss O'Keeffe's artwork in the green room at the White House. And so there was a reception, and I went with my mom, was able to get me and my sister invited to it as well. And we had dinner before, and I spilled chocolate ice cream on my shirt. So here we are. We were already at the National Gallery of Art eating dinner there. So took me to the lab, got changed out really quick, and they were able to clean my shirt in the conservation lab right before we went to the White House.
So that made you a big believer in chemistry, huh? You're like, chemistry is capable of miracles.
It did. I'm like, oh, wow, I want to do that.
So how long have you been involved in the RTG program at Los Alamos?
I started getting involved when I became the first line engineering manager at the plutonium facility. I had worked on other isotopes, other programs that involved other isotopes, such as americium and plutonium-239, but never really engaged with the plutonium-238 side of the house. I knew there was a NASA mission. Some of the laboratories I worked in were located nearby, but I never was involved. Then right before the holiday break in 2011, my boss decided he needed to do a reorg, realign managers with different opportunities, all of that. And he handed out a brand new org chart, and my name was right next to the plutonium-238 operation. So that's how I started getting involved. I became the first line manager for that. It was a lot, but it's been amazing. I would not change what I've experienced for anything. It's been so much fun. I've met so many different people.
I bet it's pretty incredible. So when you look up at the night sky and you see the planets, you see Mars blinking there, how does it feel to be part of something like that?
It's amazing. Mars 2020 is my first full mission that I've been part of. So that's extra special for me because I was there from start to finish. So you get to see all these news articles, or I'd go to NASA headquarters and for a program review, and we'd have a presentation, and they're like, oh, well, let's show you the new images that we've captured or some of the new data that we're analyzing. And so it's kind of cool to see, like, wow, without our RTG, some of this stuff isn't possible. We can collect this information and learn all these new things, see what those worlds really look like, all because we can make a nuclear power battery that can last and keep the instrumentation running long enough to really be able to do exploration.
And yeah, because these plutonium batteries are lasting for years and years, right? Much longer in some cases than you thought that the instrument would last, at least, right?
There are satellites and rovers that are going on their second and third missions, essentially, because the power output is still there, and so they can continue exploration.
RTGs are dazzling in their simplicity. That's not to say that the engineering behind them is easy, but the power of plutonium makes it simpler than one would expect. So can you give us a simple explanation of how an RTG works?
Yes. So how an RTG works is we use the thermal energy that is generated naturally from the plutonium-238 material. We utilize it in an oxide form, and make sure that we maximize the surface area of our fuel clad. That heat is then converted to electricity, and the electricity then goes on to power the instrumentation. So you're starting off with heat and you're ending up with electricity that gets converted. And so the power is really driven by that heat, and that's what allows us to use plutonium-238 and nuclear power in environments out in outer space, or in areas where we can't regularly rely on solar power, as an example. So if we don't have reliable energy sources, that's where nuclear power comes in. So you're converting heat over to electricity.
So in The Martian, when Matt Damon digs up that plutonium source and uses it to heat himself, to keep himself from freezing, can Los Alamos claim that we saved Matt Damon?
I would, yes. That was so exciting when I saw that in theaters, and I'm like, oh my gosh, there's our RTG, that's ours. Yes, when he's digging it out and he puts it right next to him, and I'm like, yep, those suckers are hot.
It would do the trick, huh?
It would.
Like a lot of other parts of Perseverance, these radioisotope thermoelectric generators, or RTGs, come about from the hard work of multiple institutions and laboratories. One of those playing a key role in RTGs is the National Nuclear Security Administration.
I'm Lisa Gordon-Hagerty. I serve as the administrator of the National Nuclear Security Administration at the Department of Energy. NNSA plays vitally important roles in administering NASA programs. Because of the unique programs under the NNSA, which includes our national laboratories, some production sites, and other locations, because of our strong role in nuclear deterrence. The U.S. Atomic Energy Act of 1954 authorizes us to produce systems for NASA using special nuclear material. In this case, we have an agreement with NASA, and we've been providing them with RTGs, the heat sources, if you will, for space exploration. So because of the unique expertise at our national laboratories, we've been able to support NASA in all of these missions for decades in the past and going forward. So we're very excited about this. Since we do produce special nuclear material, it would make sense, since we also handle it, that we are the appropriate organization to be able to administer these programs for NASA.
So can you tell us about the three locations, the three NNSA locations that help with this project?
The Department of Energy is focused on three main locations, one of which is an NNSA National Laboratory, Los Alamos National Laboratory. It is also supported by Oak Ridge National Laboratory and Idaho National Laboratory. All three play vitally important roles in producing the plutonium oxide for the heat source, and Los Alamos is where we actually put it together and then deliver the RTG, the heat source, to NASA. We've been doing this since 1961, so we've got over 5 decades of experience in providing RTGs for space exploration.
Why are RTGs a good power source for space exploration?
RTGs have been used by NASA as the main power source for U.S. space exploration since the early 1960s. In fact, RTGs have powered more than 25 space vehicles, from the Pioneer missions that once explored the solar system to the Curiosity rover and now Perseverance. In fact, it also powered the Voyager spacecraft that was launched in 1977 that's still touring the interstellar space. It should also be noted that the PU, the plutonium that is used for these heat sources, is different than that we use for our nuclear weapons stockpile.
So what are you looking forward to learning from the Perseverance mission?
Well, we've already learned so much from the Curiosity rover that's been on Mars for the last decade, and it's still going strong. Perseverance mission is looking for any signs of life that have ever existed on Mars. We know that lakes, rivers, streams, and oceans are part of the geologic history of Mars. While we haven't seen any evidence that there is liquid water on Mars' surface for more than 3 billion years, it may tell us that Mars was indeed once habitable.
This is the personal part of, is space exploration something you've always been interested in? And do you have any childhood memories related to space exploration that were particularly exciting for you?
I can't imagine any child not looking up into the sky and thinking about how exciting it would be to be able to travel to Mars, travel to the moon, and travel beyond. As a child, I remember as a very small child, the day the world stopped and everybody turned on their TVs to watch man step on the moon for the first time. And as I say that, I still get chills. And as we just celebrated the 50th anniversary, it was exactly that. It's still that today. I've always cherished those memories. And every time I've been a part of the NASA space exploration, which I've been a part of for the last 30 plus years in some small way, I look forward to being part of it again, no matter how small a measure or how perhaps important the role is that NNSA plays in supporting NASA and its space missions. It's always a thrill to me to say, well, that perhaps I wasn't able to travel to Mars, but maybe a small part of me is going there too.
Thom Mason is the director of Los Alamos National Laboratory, but it just so happens he has seen the other side of the Perseverance rover when he served as the director of another laboratory that's involved in the mission. You were also the director of Oak Ridge National Lab, so this is a bit of a continuation. You're getting to be part of this RTG mission at both labs. I'm just curious, what is it cool to be part of it at two different ends of this?
All three labs involved take a great deal of pride in their support role for these NASA missions. Of course, it's not just the rovers. The plutonium heat sources are also used for deep space missions where you're going too far away from the sun for solar panels to be effective. And you know, most of us, I think, kind of grew up watching the space program as kids, and so when we get to feel like we're a small part of helping make that happen, it's exciting for everyone.
What unique expertise does Los Alamos bring to this work?
Well, of course, Plutonium is one of the things that's really central to our national security mission and the role that it plays in the deterrent. And we've really been an expert in all things plutonium for the last 75 years. In 1944, it was Emilio Segre who determined plutonium was capable of spontaneous fission. And of course, that was ultimately what led to the development of the first atomic bomb, the Trinity test, and has supported our deterrent ever since then. Nuclear thermal rockets, satellites, nuclear power technology are really three different ways that the lab got connected with space missions. And since the 80s, we've been providing the plutonium-238 heat sources to NASA for powering space missions. And of course, now we're part of this effort to reconstitute the US capability. You know, there was a period of time there where we were relying on the Russians for plutonium-238, and that proved not to be so reliable.
And what about you? What childhood memories do you have related to space and exploration?
Well, of course, I think like anyone growing up in the 60s and early 70s, I remember the transmission of the Apollo landings, you know, on black and white TV and all the excitement that generated. And some combination of that and being an avid reader of science fiction always meant that I was interested in space exploration, you know, as an aspect of exploring the universe. And it's certainly, I think, in a way today, every bit as exciting as it was during the Apollo era, as you look at what's happening with things like the Mars rovers, and of course the really transformation in space that's been enabled by much lower cost launches through the reusability that SpaceX has brought to the equation. It's a very dynamic and exciting time.
So what are you most looking forward to learning from the Perseverance mission?
We talked about the heat source that powers the rover, but the really exciting thing is the science that it will do. And of course, the primary purpose of the mission is actually to not only study samples, but to cache them, both rock and soil samples, for a future spacecraft to retrieve them. So it's sort of a reconnaissance mission, if you will. And then once retrieved, they can be analyzed in a lab that will have even more sophisticated tools than the SuperCam that is going to be available on the surface of Mars. So we're going to be able to learn a lot more than we've been able to learn at a distance, which has already really transformed our understanding of the planet's history.
Mars Technica is produced by Los Alamos National Laboratory. Joey Montoya is producer and editor. Lexi Petronis, writer and host. With special contributor Laura Mullane. And additional thanks to Scott Falk, Charles Poling, Camille Dixon, and Arthur Bishop. Find out more about the laboratory and its mission at www.lanel.gov.